Okay. Uh, okay, first. Sekejap, lupa pula apply kat mana. Ni. Sekejap. Okay. Okay, this one. Okay, so today we will continue a new topic regarding bioenergy, biomass, biofuel, etc. Okay. So and like last week it was Shikin. Shikin presented some part of the this biomass technology, right? Okay. So okay, bioenergy. So we start. Okay, biomass conversion. Okay, so okay, as you know, biomass. The definition of biomass. What we mean by biomass is that all the wait. Okay. Okay, all the plants, etc. Right? Produce green plants produce. So these plants undergoes photosynthesis. Okay, photosynthesis that convert the sunlight to plant material. Okay, so this is like ecology, humankind's the earth ecology, right? So we kind of a cycle. So biomass will fulfill all our mankind energy needs. Okay, and at the same time they need some sort of source like carbon dioxide in order to undergo this photosynthesis process, right? Okay, so that is the part of the ecosystem. So biomass is means when we mention biomass, the definition is that is all of these living things, the organic materials, animals, all these plants, right? All of these are considered as biomass, okay, which can be used to produce biofuels and other materials, okay. So biomass is a general measure in gram or per meter square or kilogram per meter square. Okay, so like I mentioned just now, okay, so plants are called like a producer, okay, because they produce carbohydrates from the CO2, water, suns that we have here in this earth. So and it built the ecosystem with the humankind, right? Okay, so so from this plants, organisms, etc. So the decomposition of the dead organism or waste, okay, is done through the process of biodegradation. Okay, so okay, this one. Okay, so okay, more explanation on the biomass. Okay, so biomass, okay, is actually wait, um, okay, so biomass is actually the all of these all of the living, like living organism. Okay, but what is the different, a bit slightly different between biomass and fossil fuel? Okay, so biomass is the more recently a living organism, but fossil fuels generally involves the all those things that partially decomposed Asian organism, means that it has to undergo at least 100 millions of years of decomposition formation. Okay. Okay, so there is the slight difference between fossil fuel, how fossil fuels is decomposed and is made of, is formed, okay, from those ancient organisms, okay, and while biomass is more recent living organism, all the plants and the animals, okay. So what we call biomass energy is the energy recovered from this biomass, Okay, this organic matter. Okay, sorry. Okay, so history of the biomass, how it was started, etc. So one the major source of fuel of biomass since the beginning is the wood. Okay, so wood. So today developing countries use wood for about 35% of total energy supplies. So the early diesel engine were designed and tested on using the peanut oil, even guna peanut oil. This is part of the biomass as well. Okay, so okay, these others types of biomass energy that we have. We have wood, coconut husk, sabut kelapa tu, palm oil, soybean, algae, etc. Okay, those are these all of these materials, okay, are considered as a biomass that we can produce bioenergy from these materials. Okay, okay, okay. Few word just now. Sorry, few word. Okay, so fuel is especially in less developed countries, in South Africa, in maybe in India, okay, less developed countries. Fuel is the major energy source for them, okay, for centuries. Okay, so what is fuel? Can be firewood, charcoal, ships, sheets, pellets, etc. Okay, they are the primary energy source for nearly half the world's population. Okay, even some of the due to the population growth in those countries, so some of them cannot get even enough of this biomass fuel wood. Okay, because their the utilization, okay, due to the population growth, the utilization is higher than or is faster, okay, than the rate of the regeneration of the biomass. And some of the environmental impacts that this fuel could become source of air pollution and particulate matter as well. So this is example of wood used for cooking, okay, in those countries. Okay, then I'm just show this one of the study. It's quite recent, means that those less developed country, they still need and they still use this type of biomass fuel source for their cooking, etc., right, for their day to day needs. Okay, so this one is the biomass burning natural draft rocket cook stove. Okay, tempat masak cook stove. The energy source is from biomass. Okay, so nearly 3 billion people, especially in Africa and Southeast Asia, even in around our area here, depend on the biomass for their cooking needs, still depend on the biomass. Okay, so however, this we know that it produce a lot of particulate matter, which can contribute to the cancer and all other serious disease. Okay, especially towards women and children. Okay, this is not a surprise lah. Okay, because we know that the woman is the one is normally, especially in this country, woman is the one do the cooking, all the stuff. So this is the one of the impact by using this wood or this cook stove, this traditional cook stove, right? Okay, so why I'm quoting this article, actually, even though it is quite recent, 2019, means that some research have been done, even though they still use this traditional method for the cook stove. So at least they try to improve the performance of this cook stove, conventional cook stove, by analyzing the combustion process inside the cook stove. So the combustion process is the combustion process of the wood, the cook stove. Inside the cook stove, if is the conventional combustion process with CO2, etc. Okay, it's just that scientists or researchers, they try to improve the parameters, some of the parameters, the height of the cook stove, the level of the here. Uh, okay, the level of the height of the cook stove, because the process is essentially kind of like the uh when we learn about the solar PV at the facade yang double facade tu. Okay, solar PV, and they use the concept, the theory of buoyancy. I talk about this buoyancy force. Itu kan yang the less density fluid will go to the upper level, okay, at the upper level of the height, okay. So the same theory is being used in this cook stove as well. Okay, so if we increase or the height of the cook stove, maybe we can increase the combustion process, okay, of this conventional method of cook stove. So so that we can reduce, of course, the particulate matter just now, the environmental impact, the gas, etc. Okay. And then waste. Other types of biomass is waste, of course. Okay. So waste, one of the major source of biomass as well, and other burnable means materials that can be burned. Okay, produced by society, by us. Okay, so this burning solid waste only makes economic sense, means valuable, or makes sense. Okay, if the cost of the waste disposal is taken into account as well, of course, because this waste we need to burn, to dispose. So those comes with cost. So if the cost of the disposal is of this waste is higher by produce the energy that we get from the waste. So maybe it doesn't make sense, or doesn't it's not really valuable if you don't take into account the cost of the disposal as well. So that is one of the criteria that need to be considered, okay, when using this waste as a source of biomass. Okay, so but some of the benefit, okay, when using this municipal waste or solid waste, is that we can, of course, reduce the landfill volume. Sampah-sampah semua tu kurangkan. Requires a large volume and dependable supply and must be sorted. So the waste must be sort into different categories, okay, and produce air pollution, including pollutants not found in other forms of biomass, okay. But however, this waste can produce also air pollution, pollutants. Okay, the types is the crop residues and animal waste. Okay, okay, so the animal waste can also be used as biomass fuel. Okay, so how do we process this waste? Is by one of the method is by using anaerobic digester, that we call anaerobic digester, so that we can produce gas after that. So what is this anaerobic digester? So in general, this anaerobic digester is a process that that we like a breakdown, okay, break down the biodegradable material, okay, by using oxygen with in the absence of oxygen. Okay, so the chemical process of this anaerobic is, for example, like the chemical equation below. Okay, so we use an organic material, for example, a glucose. Okay, C6H12O6, that is a glucose chemical compound. Okay, so this glucose is biochemically digested, okay, into carbon dioxide and methane, CH4, by the anaerobic process, anaerobic digester. Okay, so this anaerobic process and digester can produce these three substance compound, which is biogas digested, which is like a nutrient rich substance, and water. Okay, so I have a graphic figure here. Okay, so this is the process of the anaerobic digestion. So for example, we have those biomass source for manure, animal waste, right? Wastewater, biosolids from wastewater, food waste, and other organics. So those biomass, okay, is being digested, okay, through anaerobic digestion, and we can from this anaerobic digestion digester can produce biogas. Okay, so biogas, from this biogas, of course, we can use it as electricity, as heat, fuel, renewable natural gas. Okay, and digested. Okay, as products, organic fertilizer, animal bedding, other products, etc. So those are the results, the outcome, the output of this anaerobic process. So by undergoing this anaerobic process, those biomass, those waste can produce biogas and digestate, and water, of course. Okay, energy plantations. These are the other source of biomass. Energy plantation. Okay, sugarcane, corn, grains, seaweed, palm oil, etc. Those are biomass as well. Okay, so biomass composition. Okay. What is this biomass made of? Okay, so mostly they are carbohydrates. Okay, carbohydrates, protein, and lipids, lemak. But each of these components, carbohydrates, protein, and lipids, they are valuable. Okay, we do macam lemak kita tak nak kan, tapi they are valuable. Okay, so this for example, carbohydrates could be converted into ethanol. Okay, ethanol, minyak. Okay, and then lipids could be used as a biodiesel. Protein could be used for animal feed, and the whole biomass could be burned. Okay, all of this biomass source could be burned and be used as a bioenergy, produce energy. Okay. So the concept of using all of these components of biomass, so it makes this bioenergy concept is very cost competitive. Means that we make use the whole component of this biomass to produce a lot of output. Okay, animal feed, biodiesel, etc. Okay. And then this one is okay, the same just now. Okay, so how do we convert those biomass source into renewable bioenergy, okay, technology. So first one is the direct combustion just now, like the cook stove just now. Okay, so we just burn the biomass source, okay, burn with firewood. Okay, so the combustion process, the normal combustion process. Okay, so and then we produce a heat energy. Okay, the other one is through biofuel production, right, which is by fermentation, we call it. Okay, so converts those plant into ethanol, for example. Okay, and through a metabolic process also, they can produce a chemical change. Okay, and then anaerobic digestion, like I explained just now, and the other one is pyrolysis. Okay, this is called pyrolysis. It is a thermochemical process, okay, that converts biomass, of course, to a more useful fuel such as charcoal. Okay, so those are the technologies that we have to convert the biomass source into energy. Okay, environmental issues. This one, like I explained just now. So there are about 1.3 billion people that cannot obtain wood or harvest it faster than it grows. Means that the population, the growth in the population uh, overcome the regeneration, the time that we enough to regenerate this biomass source. Okay, so, and then much forest has been destroyed because they need to use the wood. Okay, desertification, desert has increased in this region. Apa, bila kemusnahan hutan apa semua tu kan. And then air pollution, burning wood produce air pollution, smoke, particulates, carbon monoxide, and hydrocarbons contribute to ill health. Okay, so it does has cons, okay, negative impact to the environment, especially if you use the conventional technology just now, to burn the biomass. Okay, okay, that is just now is biomass. Okay, next one, biofuel. Okay, biofuel, maybe more interesting. Okay, so biofuel is a fuel, of course, that is made from biomass. Those plant material. Okay, so biofuel is being continuously and currently heavily researched on this biofuel. I will show later on towards the end some of the research, even some of research done by our department. Okay, I will show the latest results later on. Okay, so this biofuel made from biomass, the research, the study on this using biofuel in, especially in transport, public transport, even aircraft engine, is there lots being developed on this research. So okay, if we see here, especially in the European country, especially at the northern Europe and West Europe, okay. So of course, northern and West Europe, they are more developed than East Europe. Itu from historical background lah. Okay, so for example, countries that recently have more and more research regarding this biofuel. For example, Finland, a carbon neutral country by the target to have uh, to become a carbon neutral country by 2035. Okay, and they also have produce, okay, increase SAF, okay, obligation to reach their policy, okay, to reach 30% in 2030. Okay, okay, and then
Doctor,
yeah.
Doctor, what is the difference between biodiesel and biofuel?
Okay, biodiesel, kejap dia tengok. Oh, ada lagi. Ada lagi. Sekejap what is biodiesel is like one type of biofuel.
Oh, okay.
Okay. So, biofuel energy production. Okay, this is some of the statistic. Okay, so in worldwide, okay, of course, United States still the highest, okay, in terms of biofuel energy production. And then, but if you look at the region, Middle East, North America, okay, still, and Asia is less than compared to those America and Europe, okay, in terms of using biofuel production. And then this one, okay. So there are biodiesel kat situ kan. Okay, so there are several generation, means that develop research lah, study daripada first generation, per second, third, fourth, apa, makin improve lah kan. So start daripada first, mula-mula first generation of the biofuel is biodiesel, bioethanol, biogas. Okay, so those are the source. Okay, first generation of biofuel, for example, by using biogas through animal manure, animal waste, food waste, crops, and bioethanol is produced by starch, sugar, etc. So biodiesel kat situ juga. So that is the first generation of biofuel. Okay, and then study develop more. We have the second generation that able to produce biohydrogen, biomethanol, all this, and cellulosic biofuel. And then the third one is algal fuel, micro and macro algae, macam yang kat atas air itu kan, macam microorganism itu. And then the fourth, the more recent is by producing the synthetic biofuel. Okay, so these are the some of the development, research and development regarding biofuel. Okay, so just not types
Doctor,
of biofuel. Yeah.
in Malaysia, we are using the palm oil waste to produce the biodiesel. So it will fall under which biofuel?
Oh, palm oil, I think tu tak pasti generation mana tu tak pasti sangat. Tapi kind of macam apa, kita dah lama lah juga kan. Walaupun recent study masih lagi ada. I think the first or second generation lah palm oil tu, sebab kita apa tu masih depends on the plant, the first source of the biomass tu. Okay.
Okay.
Okay, and then types of biofuel. Okay, tadi ethanol. One type of biofuel is bioethanol. So it produced from plants and plant waste, etc. Sugarcane. And then biodiesel is a diesel type fluid that is from vegetable oil. Okay, for example, from soybean, sunflower, oil palm oil tadi kan. Okay, so fuel can also be processed from vegetable oils from restaurant. Okay, so those are the example of the biodiesel using biodiesel. Okay, that can be used in transport, for example, in train. Okay, and this is the apa tu, the chemical compound lah, structure. Okay, of the biodiesel. So biodiesel, the main source, the source of the biodiesel is from vegetable oil or animal fat. Okay. Okay, so it is a slightly different chemical structure than petrodiesel. So this is the at the right hand side, you can see the chemical structure compound of this the different of the biodiesel to the conventional petrodiesel. Okay, ni kalau chemical lebih detail lah. Okay, so most commonly made from soybean, palm, canola oil, etc. Okay, algae just now. Okay, so algae biodiesel, okay, the third generation just now, okay. So it is one of the possible solution as well in this biofuel, okay. Yeah. Okay, so yes, of course, many advantage, because one of them is that algae can grow in water. Okay, and if we look at this table, the oil yield in terms of gallons, if you compare algae to other, for example, oil palm, okay, the first or second generation just now, okay, so algae can produce oil like twice, at least twice, or 10 times better than those palm oil, sunflower, etc. Okay. So these are the benefit of using algae as a biodiesel. Okay, is highly productive, can grow on non-arable land. Okay, because it can grow in water. Okay, absorb carbon dioxide for growth, so it's good for ecosystem of this earth. Okay, diverse metabolism, etc. Okay, and then the challenge, however, a challenge for this algae biodiesel is a bit costly. Okay, high cost, about $1 to $2 per gallon. Okay, limited understanding of lipid biosynthesis, high value core products, and high cost to harvest. Okay, so those are the some of the significant challenge in to implement this algae biodiesel. The biggest one is of course the high cost highlighted there. Okay, uh, especially in a large scale area. Okay, for large scale of production of algae, so we need until now they have not really been proven whether this algae biodiesel is can is valuable in terms of costing, especially on a larger scale area. Oops. Okay. And this is a video, tak apa kita skip video tu. The process of the of making algae biofuel. Okay. Okay. So saya habiskan. I finish this slide first. Okay. Biofuel. Okay, so some of the advantage and disadvantage of using this biofuel. Okay, first advantage, of course, can reduce CO emissions, CO2 emissions on in those particulates, and it is renewable. However, we are still facing these problems. Slightly increase in nitrogen oxide, higher cost. Okay, and it competes with those growing food plant. Okay, and poor cold temperature performance. So those are the disadvantage that we are still facing by using this biodiesel biofuel just now. Okay. Okay, next is solid municipal waste. Okay, I think we take a break first before we continue this topic. Okay, kita break dulu. Boleh?
Okay, Doctor.
Okay. Sekejap, macam biasa 7 lebih kurang 7:30 lah kita datang balik. Okay. Okay, are you all here? Okay. All of you are here? Shikin, Ajin,
Yes,
Safaiza.
doctor.
Okay.
Yes, doctor.
Okay. Maybe we can watch the video about the algae production just now because it's only 2 minutes. Sekejap je. This one. Tak ada full screen ni. Mesti terakhir.
Making fuel from algae sounds like science fiction, but that's the goal at Pacific Northwest National Laboratory. Engineers have created a new way to turn the green goo into energy as part of an effort to reduce use of traditional fuels like oil, which contribute to climate change.
Well, solid biomass is not something that you can put into a car or into an engine. We need to change it chemically and physically. Our recent publication of our results describes our work in a continuous flow reactor system. It's
Sorry, saya macam tak boleh nak full screen kan dia sebab saya share tab kot. Tak apalah ya. Tak boleh nak full screen kan.
actual processing design that could be scaled up to large scale for actual production of real fuels.
The process subjects algae to very high pressure and temperature, the same conditions within the Earth that transformed algae to oil millions of years ago. It's a seamless process. Engineers put algae into the reactor for less than an hour, and out comes crude oil, water, and some usable byproducts.
This is the algae feedstock that we use in our process. It is about 80% water at this point in time. Once we put the algae through our processing system, it's converted into this type of light bio-crude oil. Final step of the process is that bio-crude into a finished hydrocarbon product. That's what is in this jar. It's a mixture of gasoline and diesel range hydrocarbon materials.
We can make fuel from algae today, but it's not easy or cheap. This research simplifies the process dramatically, a key step toward lowering the cost of
Okay, just share video tu kan. So we continue the slide just now. Sekejap, Okay. Oh, dia tekan. Aduh. Okay. Wait. Share screen. Tadi. Sorry. Okay. Kecil kita jumpa pula. Kecil Okay. Okay, we continue here. Another source of biomass is from solid municipal waste just now. Okay, so municipal waste. Okay, so there are several types of classification of this solid municipal waste. The most important one maybe that we know is the biodegradable waste that come from the food, kitchen waste, paper, those mostly those the one that can be recycled. any organic matter in waste which can be broken up into carbon dioxide, water, methane, etc. And then we have electrical, electronic waste, composite waste, toxic waste, and biomedical waste. So those are considered classified as the solid municipal waste. Okay, so in order to these municipal waste, there are kind of like a pyramid, okay, to produce to process this waste. So from the least favor option to the most favor option, okay, how are we going to manage this waste, okay, waste management. Okay, the least one is of course is if we just dispose dispose those municipal waste without recycling or manage it recycle, reuse or anything. So the first one is the least favored option. Energy recovery, recycling, reuse, minimization, and of course last one is prevention, which is we try to cut or use less waste that cannot be that we know that cannot be recycled or cannot be cannot be degradable. Okay, so recycling in Malaysia. So data from solid waste management SW Corp in 2018. Okay, so our country, our recycling rate is about 0.06%, which is equivalent to about 1,800 tons. Okay, and the household recycle, our house rate is estimated around 9.7% nationwide. Okay, but it was long ago, 2011. But according to a state, we have Kuantan, which has the highest household recycling rate, and Sabah ranks the lowest, about 4.5%. Okay, and currently in our the past Malaysian plan, our national goal is to manage to achieve a rate of around 40% waste diversion from landfill and 20% recycling rate by 2030. Okay, but I didn't get the latest data how much that actually we able to achieve. Okay, these are the before last year and before previous years. Our recycling management, solid waste management in our country. Okay, and then some of the policy framework that we have. Again, this is in 2018. We have country, we have a policy framework in for this one is for a sustainable oil palm biomass electricity generation. So we have short term, medium term, and long term strategic planning. I just show example here. Okay, how we going to plan this implementation of sustainable oil palm. Okay, so currently we are at should be in the medium to long term range planning. Okay, tak apa yang I just show is we are not going to read one by one. Okay, next is the overview of the biomass thermochemical conversion technologies in Malaysia. Okay, so these are the breakdown of the policy and action plan that we have currently development in biomass. So we have those policy, renewable energy policy, bioeconomy transformation, etc. Okay, and then these are the companies. Okay, just so that we know the companies in Malaysia that involved in biomass conversion. Some of the example. Okay, sorry. Okay, Samdabri produce biochemicals from oil palm biomass. Okay, so and then we have FGV Holdings, Berhad. Okay, so some of the company maybe we have heard, and some of them, me myself I never heard before. Okay, so those are the overview of the biomass companies in Malaysia that involved in this biomass conversion. Okay, what is more important, I want to show some of the research done. Okay, this one is concerning biodiesel. Okay, biodiesel just now. Okay, so it's actually this. Okay, this is quite latest, quite recent, in published in 2021. Actually, this research is part of our department. But me myself is, I'm not the principal investigator, but a part of the team, co-supervise. This about using biodiesel blends, studying on different types of biodiesel blending alternative fuel in order to for application of a turbojet engine. Okay, so turbojet engine is one type of aircraft engine, of course. That is more used in military high speed aircraft. Okay, so one of the findings that the research have found is that you compare the specific fuel consumption is actually one of the performance evaluation for aircraft engine. To characterize the performance of aircraft engine, usually we use this parameter, specific fuel consumption. So it is in terms of gram weight to kilonewton, the force, the brake power versus the brake power. Okay, so so that if we are able to reduce this parameter, this specific fuel consumption, means that the fuel is being minimized, so that the engine is considered as a better perform, a better perform engine, produce a less fuel consumption, means less fuel. Okay, so that is the one of the objective usually, is to minimize the production of the SFC, we call it SFC, specific fuel consumption. Okay, so the major findings from this research actually is still undergoing this study. Okay, so this is the first findings, is that we are able to find the alternative fuel that we name as POM and T-POM, okay, as biodiesel fuel, by using a simulation software, gas-13 software, for the application of a turbojet engine named KingTech K18TG. So that is the name of the turbojet engine. Performance and emission characteristics, and at the same time, apart from evaluating the performance, we also have to consider the emission, okay, the gas emission, of course. So that is one of the important criteria as well. So 5 types of dual biodiesel blends were mixed. So here in this study, we mix at least two types of biodiesel, okay, and to see which which blends that can produce the better performance. So this the and it is being compared with the reference, which is jet A fuel, the conventional diesel types fuel, for especially for aircraft. Okay, so we have B10, B30, etc. That is the name, okay, for this alternative fuel B blend. So from this study, we have found that B10, the type B10 jet, the green one, the B10 blend, the jet fuel, achieve so far the better fuel consumption, because it is the lowest. Okay, the lowest means that we can minimize the utilization of the fuel. Okay, the green one, especially compared to the conventional types of fuel, which is the Jet A. Okay, Jet A in blue, dark blue. Okay, is the only one in terms of specific fuel consumption in able to reduce the SFC compared to the conventional. Okay, however, still the B30 and the B50, okay, jet blends were close to Jet A. So even though the other blends, B30 and B50, the SFC is higher, but it still can be considered since it is close to Jet A, the conventional fuel. Okay, means that even though it produce a higher SFC, but maybe we can still consider this blend, this dual blend biodiesel, if we look in terms of the environmental impact as well. Okay, if you look at the environmental criteria as well, maybe we can also consider B30 and B50. So in terms of carbon monoxide and carbon CO2 emission, the B10 jet blend produce the lowest emissions of jet A fuel. Okay, so and the best perform. Okay, thus the performance of the dual biodiesel blend was better than that of the single biodiesel blend. So overall, at least we have B10 perform better than the conventional in terms of SFC and also in terms of the emissions, gas emission. And then from the same study, but different publication, but from the same team study research. Okay, this is kind of like a review of those summarize all of the biodiesel's blend ability, the effect of biofuel on engine emissions and its effect on the engine performance. Okay, so if you look at the first one on the left hand side, okay, so those biodiesel blends emits less, more or less hydrocarbon, HC, carbon monoxide, and nitrogen oxide. Okay, and then on the left hand side, the effect in terms of biofuel engine performance. Okay, BTE is the thermal biodiesel thermal efficiency, SFC just now, and the brake power produced. So different types of blend, biodiesel blend. Okay, all biodiesel and their blends have demonstrated the ability to reduce emissions, okay, under various operating conditions, as well as the ability to improve the performance of the gas turbines. Okay, it is necessary to understand the combustion properties of fuels for their use in an engine. That means that is one of the important criteria that we need to take into consideration is the combustion process. Okay, the property of the density, viscosity of those fuel. The contribution of this review is to help the engine manufacturers and researchers develop further research relating to readjusting and optimizing the biodiesel engine and its relevant system. So from this review study, can help, okay, advise future research where to optimize the utilization of this biofuel in gas turbine engine. Okay. And then other research, okay, this is not from UPMs, but I'm just share this with you because it's quite interesting application of biomass. Okay, so one of application of biomass technology is of course for generation of heat and power. For house, usually small scale. If it's small scale, it's usually for normal household. Okay, so this biomass source technology can be combined with an engine that is called Stirling engines. I'm not sure if you have heard of this before. So Stirling engine is like actually it is kind of like a diesel engine, but it is external. We characterize it. We call it as a external combustion engine. So so opposite than the internal combustion engine that we usually heard of or use, ICE, internal combustion engine. So Stirling engine is external combustion engine. So it has a potential of being run by an external heat source. Okay, saya just explain sikit lah. Maksudnya macam kalau biasa kita guna ICE lah kan yang kita biasa dengar dalam internal combustion engine yang kita biasa guna kereta, vehicle apa semua. Dia apa tu engine tu dia run based on the combustion, okay, fuel tu kan dengan air inside the engine the vehicle lah kan, dalam engine tu dalam combustion chamber ke apa kan. So that is called as internal combustion lah. Tapi bila external combustion ni, the heat source tu which here the heat source is the biomass. Okay, so the heat source tu boleh datang daripada luar daripada enjin tersebut. So ada of course ada pro and cons, but the pro, I mean the benefit is advantage is that the external heat source tu tak semestinya daripada dalam enjin tu lah, maknanya dia boleh guna asalkan dia ada different of heat exchange daripada luar, enjin tu boleh start to run. Something like that lah, simple general explication lah. Okay, so this one, this concept is by integrating the biomass with a Stirling engine. So the source, the heat source comes from the burning of the biomass. So once the Stirling engine, this one yang ni kan, Stirling engine ni dia ada dia punya macam tube. Okay, ni betul ada there are two A and B configuration of this combined biomass and Stirling engine. So once biomass is being burned, combustion of the biomass kan, dekat dalam ni fuel and ada primary air, secondary air apa semua. So the heat from the biomass can be absorbed or kind of like captured by this tube heater. This is a heater of the Stirling engine. So it's like the normal thermodynamic process, engine cycle process. So once it has a heat source which comes from this heat combustion of the biomass. So dia ada heat source tu, and then dia can produce the change of the heat, so it can produce heat and power. So that's why we call it, I think this one you have heard about it, cogeneration. Cogeneration means at least two generation, production, which is a heat and power. It can produce a mechanical power and heat at the same time. Okay, so there are two configuration how the process of this integration of biomass. So one type kita buat macam A tu, second type is the updraft gasifier with post combustion burner. So ada beza lah dari sudut production dia. Okay, so the application of solid biomass fuels for small scale cogeneration of heat and power is a central issue for base load energy supply in terms of fluctuating renewable energy resource like wind or PV. Okay, therefore especially micro to small scale solution offering fuel flexibility and easy handling are of special interest. Okay, so kat sini actually this just small I just derive a small part of this review paper sebab of course dia panjang lagi. So nak cakap the main issue that makes that we derive this integration biomass dengan Stirling engine ni because it's more simple kind of a simple process compared to the in terms of for small scale generation, in terms of other renewable energy. Instead for small scale cogeneration, maybe we can consider this biomass with a steam engine, because the simplicity and easy handling of this concept. Sebab dia guna external, one of the interest is that dia guna external tu, so dia macam lebih mudah lah, they can come the heat source tu boleh daripada banyak jenis. Sebab tu one of the interest lah. Okay, so this technology can be applied maybe to since it's small scale, so maybe to a household. Okay, and then the same thing, still combine heat power, micro combine, still small scale, micro scale, combine combustion process of biomass and this steam engine. Okay, so the same concept, integrate the biomass source, which is can come from the biofuel power plant, and then integrate it with a steam engine. Okay, and this combined technology can produce a micro heat and power system for to produce heat and power. Okay. Lepas tu, okay, next, continuation from the same paper. Because this paper is study on the different working fluid, okay, of this biomass steam engine. Okay, so that in the steam engine we still need working fluid, which is usual thermodynamic cycle. Macam biasanya kita ada air, helium ke apa ke kan, gas. But here it propose that we use nano fluid, because we know that nano fluid has higher convection heat transfer, usually due to the characteristic of the nano fluid. Okay, so depending on the biomass fuels, the types of biomass fuel here, prunwood, poplar, bagasse, etc., sawdust. So we compare those biomass source, the mass flow rate of these biomass fuels, and how much power it can produce by using this micro MCHP, we call it micro combined heat and power. Okay, so a typical MCHP system, micro heat and power, micro combined heat power, integrated by gamma type steam engine, a type of steam engine, gamma, to meet electric heating and hot water demands. So means that we can apply this one. There is a possibility to apply this one in a small scale application. And then the test result confirm that steam engine driven by the biomass gas are able to achieve a valuable output power. So there is a potential by using this biomass steam engine. The highest efficiency was achieved when using sawdust biomass, and the lowest was achieved when using prune wood. Okay, due to the difference in their gas heating value. So depends on the heating value. So each material they have different heating value. Heating value ni lebih kurang macam kind of like specific heat jugalah for each fluid. Air pun ada fluid specific heat kan. Water also. So those biomass source has different heating value. Means that the rate of the heating value is in kilojoule per kilogram. So the rate of the energy that can be produced by each kilogram of those biomass. So if we if mentioned here, the sawdust, which when using energy, okay, due to the difference in their gas heating value. So if a sawdust has achieved highest efficiency, so means that sawdust has a higher heating value, means per kilogram of sawdust, can produce a higher energy joule compared to the lowest prune wood. Okay, so the total efficiency varies. The total efficiency of the whole system, the micro MCHP using biomass and diesel engine, is around 9% to 30%. Okay, and the table below is the results of different nano fleet type in the working fleet of the steel engine. Okay, so those are the efficiency, and then this one still so again kind of the same. Design, fabrication, evaluation experiment of the steel engine with biomass, again for micro CHP system juga. Okay, so kalau if you can see here, just tak besar sangat. Okay, mana tah? Okay, so this one is this is the same heating, the heated tube. Okay, the heated tube of the steel engine. So this is the combustion chamber. So we burn the biomass inside here. The biomass is burned inside the combustion chamber, the chamber, and then so the heater. This is the heated tube of the steel engine. Once it sense the difference of temperature, macam the normal heat exchanger kan, normal heat exchanger is to exchange heat between two different medium of temperature. So once there is a difference of heat, okay, between the heated tube, this heat exchanger and the heat source, which is comes from the biomass. So the engine will start to cycle, will start to process. Okay, so that is how this micro CHP biomass and steel engine concept works. Okay. Okay. So itu je lah some of the sharing on the findings, okay, results. So I just choose study, basically study that we our team in the department have done, because this one just now the turbo jet engine, of course, for application of gas turbine and aircraft engine. And this one actually steel engine and biomass is one of the topic that I study as well. But this is not my findings. This is from a literature review. But this concept is being considered has a very great potential to produce a small scale power. Okay. Okay. So that's all from me for this biomass, bioenergy. Lastly, I just has one example. So like before this, how do we design and calculate the electricity used in a house? Okay, by using this biomass wood pellets. Okay, maybe we can just try to look at this example. Very simple, small simple example. How do we can save, perhaps instead of using conventional furnace, we use this wood pellets biomass source as a heat source for heating of a household home. Okay. Okay, so we try to look at this one. So a homeowner is currently using a propane furnace. Okay. propane furnace for heating the house in winter, but he is considering replacing the system with a furnace burning wood pellets. Okay, the homeowner currently pays an average of 2,500 per year for space heating. Okay, so setahun annually, he has to pay $2,500. Okay, by using the propane furnace. Instead, using the values given below, the information that we have, determine how much the homeowner save from heating per year if you replace the existing furnace with a pellet burning furnace. Okay, just you want to estimate, do an estimation how much we can save in a normal household, how much we can save if we use instead a biomass source, bioenergy source for heating of a house. Okay, so here we have to compare between propane furnace and wood pellet. So HV is the heating volume I mentioned just now, but here it is in British convention, British unit, BTU over pound mass. Okay, so actually BTU is the British unit for joule energy. Okay, so so propane has heating value 21,640 BTU over pound mass, and then the efficiency of the furnace is around 0.85, and the unit price for each weight pound mass of the propane is 0.80 cents. However, by using wood pellet, okay, less heating value and a little bit less efficiency. Sorry, bukan furnace itu, typo. Efficiency of the wood pellet is 0.8. And the unit price is 12 cents per pound, mass pound. Okay, so we just have to compare and estimate how much we can save by replacing the wood pellet to instead of using propane. Okay, so okay, oops. Okay, first maybe we need to calculate the heat, the price of the heat supply by this propane. Okay, means that how much for each energy BTU, a joule or energy of the propane, how much is the price? Okay. So, so for propane, I write it as unit price. So unit price of heat for propane, the conventional used to heat the house. Okay, we have just now, so unit price for each mass is 80 cent, okay, per mass, pound mass. Okay, and the efficiency is 0.85, so we divide by the efficiency, and we know that the heating value, because we want to calculate the price of each the price per energy produced or per BTU produced. Okay, so the heating value, so that's why we need this heating value of the propane, which is 21,640 BTU per LBM, pound mass. Okay, so that's how we get the unit price for the propane in dollar per BTU, because we can cut this, kan, dollar per BTU. And then the other one is unit price for pellet, wood pellet, okay, by using the biomass. Okay, so again the same, the price of the unit price of wood pellet is 0.12 per lbm, and the efficiency is 0.8, and then the heating value is 8,500 BTU lbm juga. Okay, so can just calculate using calculator how much the value of this both of this unit price. So just calculate first. Dapat ke tadi yang unit price untuk propan? Shikin dapat tak yang first yang propan tu? Ada try?
Sekejap tengah kira ni.
Okay. Boleh stop Okay, boleh stop sharing. Mana tadi? Terlift. Okay, kalau dapat kira apa tu calculation tu boleh bagi tahu yang unit propan dengan unit pellet tadi tu. Dia tak ingat.
Propan 4.35 10 power 5.
Okay, per BTU tu lah kan, per energy tu. Try.
Yang wood tak sempat nak salin dia punya.
Oh, sama je. Method dia sama je. 0.12 cent tu over efficiency times dengan LV tadi tu.
Yelah, value tu tak nampak.
Okay, sebab saya nak buka yang satu lagi tu, dia internet connection ni pula, tak apa, saya guna yang ni je lah. Sini. Okay. Dia nak buka yang satu lagi ni.
Yang nombor 2 tu 1.765 darab 10 kuasa negatif 5 pellet.
Ya, betul. Okay. So once dah dapat we get the unit price of gas ni, kita kena we have to calculate the annual pula, annual value, okay, of the pellet tu lah. Sekejap, mesti tak nak contoh yang ni. So how do we calculate? Okay, annual pellet cost tu, okay, cuba cakap, ya, cuti sikit. Kat sini lah. Sini.
Doktor.
Ya.
Pound mass apa beza dengan pound saja?
Pound saja, pound ada banyak, bukan banyak, ada pound weight, ada pound mass, ada pound, ada unit lain juga. Sekejap ada pound in terms of force. Pound force pun ada juga ni, tapi ni semua British punya ni lah, form of writing lah, unit dia.
I see. In this case, weight lah.
Yes, weight,
Okay.
pound mass, bukan force lah. Kalau force dia tulis LBF, dia punya notation tu. Ni LBM mass lah. Biasanya dua tu lah yang biasa guna. Betul tadi, dekat sini lah. So we have to calculate the annual pellet cost. So annual pellet cost, annual from the annual propane cost just now yang 2,500. The homeowner currently pays an average of 2,500 per year for space heating by using the propane kan. So times the unit price of the pellet over unit price of the propane tu lah. Okay. So we get the estimation of annual pellet cost tu. Okay. So 2,500. Ini tadi yang value yang kita dapat tu lah. Pellet tu tadi 4.35 and power of 5 lah. Susah tu kita power of 5 kat sini. Tapi faham and divide by berapa tadi 1.7 1.776 or 765. Again 10 power of 5 juga. Okay, so sini. Okay, so that is how we get the annual pellet cost, and then how much to saving we save. Saving tolak je lah the saving annual pellet cost tadi ni dulu propane cost minus the annual pellet lah. Obviously we expect the by using pellet the cost is less, it's being reduced. Okay, so how much the difference is the saving that we expect to need to meet. Okay. Okay. Saya try sekali lagi masuk Reddit. Tak apalah. Okay, lastly, before we finish, okay, like I mentioned just now, I'm going to give you another a second assignment. Okay, share step. Okay, so this second one is okay, kind of the same, not really the same as the first one. Okay, so it is more towards application of the renewable energy for built environment. Okay, so just that. Okay, here the instruction, propose a renewable energy system for building environment in Malaysia. So here I have a sign, but maybe you can, if you don't like, or maybe you can change between you guys. If you want to change the building, the type of building. Okay, so there are 4 types of building that I propose. First one is a normal family household, but located in a city. Okay. And then second one's also a household, but more in rural, kampung lah kan sikit, rural part. And then an office building, or it can be, because just now when I heard Anas do the study about the school building, maybe you can replace also with school building, because the objective is that I want to compare the building with around the medium level, 3 to 5 maximum level. Kalau sekolah 3 je lah kan, lebih kurang tak tinggi sangat, ada lagi tinggi, the kind of floors tu, height dia tu lebih kurang banyak ni lah targetnya. And then a high-rise building, maybe office, higher office building or hotel, boleh jadi. Okay, so that is the 4th type. So the idea is that macam propose any renewable energy system untuk building environment. Contoh macam it can be not only one, but maybe can integrate several types. Contoh solar with wind ke kalau sesuai untuk rumah tu kan. And or tadi macam with another engine yang macam biomass with another engine yang boleh produce micro cogeneration just now, like micro cogeneration tadi. But of course depend, tengok dia punya cost and impact dia lah kan, energy consumption apa semua. And then present. Okay, so this time you don't need to write a report. Okay, sorry, habis saya kena, tak perlu ni so kali ni simple sikit. Okay, tak perlu report, just prepare slide presentation or poster presentation also can. So like the first assignment, we just present and try to discuss this renewable concept. Okay, so expected in 2 weeks, just before the semester break, which is I think 1st December, in 2 weeks. Hari ni dah 16 17. Okay, so in 2 weeks, so but no need report, you just prepare a slide presentation. Okay, so that's all lah, itu je. So maybe like just now, just around 5 page slides pun okay, maximum 10 macam tu. So have a bit of background study, and of course the reason, the argument why you propose those system lah untuk different type of building ni. Okay, boleh tak? Okay ke? Jadi saya share ni.
Boleh elaborate more on apa inti dalam assignment tu tak, Doktor? Nak masukkan apa?
Okay. Tadi buat report. Okay, first kali of course macam literature juga sikit, tapi tak adalah ekstensif sangat. So macam background sikit mungkin after you search apa sistem yang ada ataupun yang possible, mungkin you can ambil daripada luar negara juga. Cumanya lepas tu bila nanti nak apply tu, reasoning tu compare dengan keadaan location dekat Malaysia lah. So ada literature review sikit kan. Lepas tu the pro and cons of the system yang you propose lah, kan. Itu je, macam tak perlu detail sangat lagi lah, sebab nanti kita akan, insyaAllah kita akan sambung lagi nanti dalam the second after mid break tu. Kita akan tengok lagi detail lah macam mana dari sudut dia punya energy balance, apa semua tu kan. So kat sini macam idea just to from the do some background study, she review tu background study, and then apa possible proposition lah, apa possible application untuk this type of building ni. Okay tak? Okay.
Okay, Doktor. Terima kasih.
Doktor,
Ya.
do we need to sketch any design of the system?
Okay, of course kena ada diagram lah, gambar lah kan. Tapi diagram tu can be tak semestinya lagi daripada original drawing, korang punya drawing, you guys punya drawing. Boleh ambil daripada any literature. Maknanya kena ada drawing, cumanya bukanlah kena draw sendiri lagi lah. Tapi boleh juga kalau macam idea yang awak ada tu mungkin belum ada lagi lah kan orang buat ke, tapi maknanya combine campur-campur integration system tu. Itu kalau macam tu maybe you have to draw by your own self lah, the proposed system tu.
Okay.
Okay, ada any more question?
Doctor, one more question, Doctor. Okay, let's say for the high-rise building, right? Okay, let's say contohnya kita nak, okay, the